Welcome everyone to the fourth Science and Conservation event as part of our 2023-24 program. My name is Tom Letessier, and I'm a research fellow at the Institute of Zoology. I have made it my life work to understand and to protect marine wildlife in their ecosystems, and I will be your host this evening. The format for tonight will be 4 short presentations from our expert speakers, 2 which will be delivered online. It was Thomas Hobbes who famously suggested that the state should be seen as a benevolent force with reference to the mystical Leviathan of the Bible. Hobbes' thesis was that a natural and violent order could be avoided by a strong and legitimate state. This hypothesis concerning the role of the state was put to the test in October 1969 when the Montreal police force went on strike. And in the resulting 16-hour riots, 30 people were injured, almost all the central banks in Montreal were robbed, and 1 police officer was killed. Ultimately, the army had to be called in order to restore order, arresting over 100 people. It's unknown how interactions between human and wildlife changed during the Montreal riots. Presumably, it was low on the list of priorities with which to deal. And in any case, it would have been hard and difficult without modern tracking technology. Tonight's event will show us how advances in biolocking and vessel tracking has enabled scientists to tackle this issue directly during the recent global tragedy of the COVID pandemic. And hopefully answer the question, how did human-wildlife interaction change during the lockdowns? And I'm hoping it will leave you with a nuanced view of humans both as threats, but also as custodians of nature. Our first speaker will be IOZ's own Claire Collins. Claire is a postdoctoral researcher at ZSL and the University of Exeter. Her research focuses on understanding human dimensions of socio-ecological systems, which previously involves including the importance of shark fisheries, drivers of fishers' spatial movement, and understanding perception of conservation management policies for improving marine protected areas' effectiveness. She works across research, government, and consultancy bodies, and is particularly interested in how collaborative actions can enhance compliance with conservation management policies to enhance their long-term effects. Claire, please join us.
Okay, thank you very much, Tom, and thank you for inviting me to speak. I am going to be talking, I'm going to take us to the marine realm first. So I'm going to be talking about marine protected areas and what happened in one specific MPA, marine protected area, during COVID, specifically focusing on illegal fishing and changes in that during COVID. And this is a case study system that I've been working on sort of throughout my PhD and onto my postdoc here at ZSL, but also at the University of Exeter as well. So what happened in protected areas during COVID? So basically there was sort of 2 key sort of changes that happened that impacted on sort of illegal sort of activities. So firstly, COVID caused some devastating socio-economic hardships for people that were living sort of in and around protected areas or that used it traditionally. And these sort of hardships potentially drove illegal activities as people lost their livelihoods, lost their incomes, etc. And in addition, government and sort of organisational priorities shifted as priority was safeguarding human populations and including safeguarding sort of rangers and enforcement personnel that work in these protected areas. And that meant for many protected areas globally, there was actually sort of a reduction in monitoring and enforcement, so ensuring that people were complying with MPA policy. So this sort of led to a very unfortunate incidental experiment in management of protected areas, and sort of how changes in these two factors might lead to sort of increased pressure on them. So why does that matter? So why do we care about learning lessons from this? So socio-ecological shocks such as COVID fortunately don't happen all of the time. However, there are lots of sort of smaller socio-ecological shocks that are occurring frequently globally. And it's important that our protected areas are resilient to these. So it's important that we identify learnings to enhance management for the future, because these protected areas are contributing to sort of our social ecological sustainability moving forward. So for livelihoods, for the protection of species as well, sort of fisheries, etc. So we're focusing specifically on large-scale marine protected areas today. So these are any that are over 100,000 kilometres squared. And why it's important to study these is because the majority of our globally protected marine area is actually within sort of several of these really large areas. So 75% is within these areas, and a lot of these sort of larger ones, such as the one we're going to talk about today, sort of like Pitcairn, Pacific remote islands, they share some similar characteristics, and a lot of them are sort of like what we'd say remote. So they don't have lots of human populations living there. They're quite far away from sort of like markets, from sort of like where fishers might be leaving from. And that also means that they share sort of similarities often in how they're managed. So a lot of them rely on sort of patrolling. So they rely on like a vessel system, which we're going to think about, and that has considerable sort of resources, but it has to be thrown at it as well, because these are large areas. It also means that people rely on sort of satellite technologies as well. So trying to understand where vessels are, using these satellite systems on top of vessels, and using that to inform patrolling and enforcement. And also a lot of them rely on what's called like sanctions-based enforcement. So basically economic fines, such as confiscation of gear, or sort of just fixed penalties when people are non-compliant within them. So the large-scale marine protected area that I work on is called the Chagos MPA, and that is kind of sort of western central Indian Ocean area, so just under the Maldives. Very much is remote. It's a really sort of long distance from any like sort of key ports, and it is 640,000 kilometres squared, so it's really quite large, and it was designated in April 2010. And since then, ZFSL have been working there through the Bertarelli programme in marine science, and it has suffered consistently from illegal fishing. So the kind of red sort of dots on this map here indicate where illegal fishing activity is sort of peaking. So it tends to be the shallow reef systems, and it's mostly by the Sri Lankan vessels traditionally. So these are sort of small vessels, 5 to 7 crew on board, and they tended to be targeting sharks in these reef systems. So they were travelling 7-8 days or something like that from ports, mostly on the west, south of Sri Lanka, in order just to target sharks in Chagos. However, during COVID, there was some sort of key shifts. So from April 2020 to August 22, no vessels were boarded. So currently, it's you have a patrol vessel, and they go on board, and they have to collect evidence to sort of ascertain what these fishing boats are doing. But that just completely stopped during COVID, and that massively reduced the likelihood that people were going to be punished for conducting illegal fishing. In addition, you had some really important social economic context in that they're primarily from Sri Lanka, and there was a series of economic crises in Sri Lanka during this period, which affected fuel, for example, massively, which is obviously important for fishers that are travelling so far. And what we started to hear anecdotally from the enforcement personnel that were on board this patrol vessel was that illegal fishing was massively spiking sort of end of 2021. So we looked at data from this enforcement. So this is sightings of like confirmed illegal fishing activity. And we found that in 22, there was 19 times as many illegal fishing activities per month than there was from 2010 to 2020. So it's obviously a massive spike, and interestingly, it was primarily Indian vessels, so it was kind of like an inverse pattern to what we'd seen traditionally. It wasn't Sri Lankan, it was Indian vessels. And then we started to think, okay, we need to look at satellite data to see whether or not that's actually informing us of that trend, so whether we can see the same pattern. So we used sort of AIS satellite tracks on the vessels, and that actually indicated an inverse trend. So it showed that there'd be a big sort of increase in Sri Lankan activity in the marine protected area, but there was no detections of Indian vessels. So basically they were kind of dark, they were going undetected. So we started to think about why that's probably happened. So we identified first, obviously, risk, thinking about traditional theory. People will engage in activities if they think the reward is going to be bigger than the risk. And obviously, the likelihood of them being sort of fined for these activities were basically gone. So it would have been, they would have been profiting more likely from the fishing. And we looked at where the vessels were coming from, and they were all primarily coming from one sort of small area in the southern Tamil Nadu state. So thinking about how sort of information around MPA management travels within fishing communities and how important that is for getting the message out around management. And one of the main reasons potentially why we saw a massive jump in Indian but not Sri Lankan vessels was this economic crises that were going on in Sri Lanka, that Sri Lankan fishers just didn't have the money to, or they couldn't get access to fuel to continue illegally fishing in the MPA. But also, interestingly, there's what's called a bilateral agreement in place between British authorities and Sri Lankan authorities, which mean that if they are caught illegally fishing in the MPA, they will be prosecuted at national level by Sri Lankan authorities. However, that's not in place for Indian vessels, so it kind of removes one of the options for management for us. So what management lessons can we learn from this? So I think the key sort of one is thinking about how do we deter illegal activity in PAs beyond relying entirely on these enforcement style systems, so relying on vessels or patrol vessels or fines themselves. So do we need to look at other sort of socio-political tools that we have, so these bilateral agreements which would be put in place, you know, during MPA implementation and whilst they're sort of being managed, which would mean that when socio-ecological shocks such as COVID do happen, and the ability to conduct enforcement, etc., is gone, then we're not left without no ways to deter this type of activity. And also thinking about it, inferring trends about activity, primarily just from satellite technologies, is still imperfect in reality in the world that we live in, especially for fishing fleets such as sort of the Indian fishing fleets, which just don't have these types of satellite technologies installed, and they're probably unlikely to have that for the next sort of like 5-10 years in the short term. I don't know if that's me. I hope it's not. I don't know if I'm like... Is it my lanyard? Okay, sorry. Okay, so for thinking about like wider resilience for large-scale marine protected areas, so key sort of lessons are we need to build adaptivity into management across all sorts of levels. So this is not only thinking about like compliance and enforcement, but it's also thinking about stuff like finance. So for example, for some marine protected areas globally, they relied on tourism, and that was completely removed during the pandemic, and they were left without any sort of resources to manage these areas. And we also need to empower local communities and also decision makers to be able to make shorter term decisions to sort of react to situations rather than sort of waiting for the sort of bad thing to happen, which happened in this case. And that's it.
I've got one question, Claire, before you leave. Could you perhaps comment on the situation since you did your work, and how has kind of the enforcement activity tried to reestablish itself, and what has been the response in the fishing activity, and I don't know, any kind of ramifications at the community levels in these areas where these vessels are coming from?
Yeah, so I guess the first thing is that when the boarding started again in the August of 22, and these boardings were conducted now by Royal Marines, so sort of like some army personnel, military personnel that are around the island, and they did start to sort of introduce fines again and detention. So it worked in terms of Sri Lankan fishers were discussing this within communities, and they said to us, this is really scary, we don't want this to happen to us. But one of the massive learnings from it is, at the moment, they're sort of brought into this island, and the resources needed to sort of conduct this type of enforcement is massive, because there's no bilateral agreement in place with India, they have to bring Indian vessels in, and this costs a hell of a lot of money, and it would be much better if that was just done at the national level, so that the Indian authorities would do that, because it would also be a more sort of appropriate sanction system as well for the Indian government to sanction their own fishers. It would be a lot more appropriate than and a less sort of burden on the MPA authorities as well, as the key learning, I think.
And perhaps could you comment on ongoing negotiations about trying to establish that kind of bilateral agreement, or is that just in confidence?
Yeah, just difficult, basically. Yeah. So it highlights the sort of the importance of when you're implementing an MPA at that point, you need to start having those discussions, rather than because obviously when you're accusing countries of illegally fishing, it's very sensitive. So that's why it's so much better to do it at the implementation stage, rather than just waiting for it to happen and punishing lots of fishers, because then you're going to sort of cause really severe social impacts on these fishers if you're detaining them and fining them lots, and that's not necessarily going to allow you to enter a diplomatic stage in a good sort of situation, I guess.
Yeah, so it's the prep work, basically. Yeah.
Yeah, prep works.
Okay, yeah. Great, thank you. Okay, the next speaker is Dr. David March. He is a distinguished researcher at the University of Valencia, and is the team lead of the Spatial Marine Lab there. And he's also an honorary lecturer at the University of Exeter. His research employs integrated approaches to address animal-human interaction with a focus on spatial ecology, movement analysis, and marine spatial planning. With extensive expertise in ocean observing systems and new marine technology, David has significantly advanced the monitoring of human pressures and the conservation of diverse marine species. His dedication to academia extends to mentoring students and teaching at the University of Valencia, where he shapes future marine ecologists, and is joining us remotely. Thank you, David.
Hi, Tom. Thank you very much for the introduction. And yeah, well, thanks so much for the invitation. It's a pleasure to be here this evening with all of you, although remotely from Valencia. In this talk, I'm gonna present you the study we conducted. Indeed, while we were all together amidst and during the COVID-19. That time, I was working at University of Exeter, conducting my postdoc there, and working on fisheries in the Western Mediterranean. And we then realized that we were working on technology that were enable us to monitor these changes globally. So what I'm gonna introduce you here is some following topic that Claire already mentioned, this AIS, this technology, we can all monitor marine traffic globally. I guess you all can recognize this vessel, the Ever Given, that was stuck in the middle of the Suez Canal in 2021 and blocked the global trade for several days. At that time, we were all able to see in the news how all the rescue operations were taking place. We were able to see the different vessels that were put in place in order to support this operation. And we were able to see this thanks to this automatic identification system, which is a GPS tracking system that is connected to the vessel and broadcasts the position of the vessel through radio signals. Till several years ago, most of the information we were able to use from this system came from terrestrial antennas, which had some limitations in terms of the range we were able to detect the vessels. But thanks to the emergence and the advent of nanosatellites, we can now detect these signals through satellites with a global coverage. These allow us to be able to track vessels from any place in the ocean. And talking with vessels, one of the first indicators also of the COVID was this case of the Diamond Princess, this cruise that was found with known cases of COVID-19. These brought border restrictions and changes in the maritime sector. So what we did was to collect and analyze these full data set of AIS data, collecting more than 200 billion observations of vessel positions that provided information on the traffic density globally. What we did in this study was to compare the changes during January to June 2020 versus in comparison with the previous year. So we were able to identify changes, increases, but also decreases, but also some increases. You can see here in this map at the bottom, red areas identify locations where there was found a sudden drop in the maritime traffic, but we can see some blue areas, like in the Cape of Good Hope in South Africa, that presented some increases. Something we found, of course, is that changes were not all driven by COVID-19. In this case, we also find some socioeconomic drivers. For example, this increase in South Africa was mainly driven by the decrease in the fuel price, and also the increase in the taxes that vessels had to pay in the canal, in the Suez Canal. So for them was economically more feasible to follow this route from Asia to Europe rather than going through the canal, through the Suez Canal. Looking at different areas, we can see how, for example, in the top row, we can see how this tracking system allow us to identify this drop in marine traffic in European waters. In the top, we can see from April and with more deep decreases between April and June. These changes was asynchronous. We can see, for example, how the area, the Asia, China, these Chinese waters were the first one in January, where we were able to find decreases in maritime activity. And as Claire mentioned, we can also use this information to look at changes in marine protected areas like the Galapagos Islands in the E row, where we can see also a decrease from the month of April. And in this case, we can identify these changes through the decrease in the touristic activity in that marine protected area. Taking a closer look to the Western Mediterranean, that was originally the area that I was analyzing more in depth in terms of the fisheries. Here, we can see here, you can see here these dots representing individual vessels moving around the Western Mediterranean. We can have here different types of vessels, cargo, tanker vessels. We can also here, this is maybe you can see the purple point represent the fishing vessels that move out go out from the port at 5 a.m. and then get back all together very synchronously to the port later on during the afternoon. So we align these changes in the Western Mediterranean with the restrictions that the different governments, France, Italy, and Spain, implemented. We can see this through this top graph that represents the stringency index. This is an index developed to represent the confinement and the lockdown measurements. And And we can see how this well aligns very well with the decrease in the overall marine traffic in this region. But as I mentioned, with AIS, we can also track and assess the changes by different ship type categories. We can see cargo and tankers here in the top, which presented some decreases, but they maintain quite well the different activities. As you can see, the passenger vessels were the vessel category that presented a longer decrease sustained through the time. The recreational vessels, of course, they were also the one that's there was no way for people to go to the marinas. But just after the lockdown measurements were lifted out, it was for them easier, and they specifically use the recreational vessels also to escape from the confinements. For some activities like fisheries, we can also find some drops, some decreases in activities, but they were, for example, more short in time than other activities like passenger vessels. So one of the potential limitations of this technology is that AIS is based on this transmission of the signal, which sometimes vessels can switch off. Not all vessels are equipped with this technology. So different works have now incorporated the analysis of complementary information like satellites. Here in the image, we can see some examples of SAR. This is synthetic aperture radar. It detects the reflection of metallic objects at sea, and also optical imagery from vessels. And what I want to share here is the outputs of a recent paper that they've been using this information to assess what is the fraction of vessels that are providing this AIS data, making publicly available. And we can see that areas, for example, in Southeast Asia, we have a huge fraction of vessels that are not providing this information. So this is providing us some clues of the lacks that we currently have in terms of electronic monitoring of vessels. That was for fisheries. Here on the right panel, we can see an equivalent map for industrial, from transport and energy vessels. We can see here that in terms of using this electronic monitoring system is more widely used, although we can still see here, like in Southeast Asia, we are lacking information in this region. Building on this study, the authors reported similar patterns that we observed in our previous study. So they show how outside China during the pandemic there was a decrease in the fishing activity, while within Chinese waters seems that the drop was more lower. In terms of transport and energy, we can see how it affected in a more or less magnitude, almost no change in the longer term. So what this study is providing is a longer extension from our first assessment. And they also identify some even increases, slight increases within Chinese waters. However, this technology is still focusing on large vessels, but in areas like where I'm currently based in the Mediterranean, we face a huge amount of nautical activities, artisanal fisheries, and all these vessels are quite small to be tracked with both these electronic and these satellite systems. So we are using now some more high-resolution satellite imagery. As you can see here, we can detect some vessels. The ones that are with a red point represents those that are equipped with this AIS system, while the huge amount of small white dot represents vessels that are not tracked with this electronic monitoring system. So we are currently working on this. This is a current research line that we are now using these satellite imageries to provide a wider information about the human activities at sea. And last but not least, the other technology we are also experimenting with are bird-borne tags. These tags are now capable. These are equipped on show waters, and they allow us also to detect the marine radar systems that are equipped on vessels. We've been using these in the Western Mediterranean, but also in West Africa, and we've been using these also to identify vessels that were not providing these AIS systems. So this is, let's say, a next step in terms of how we are addressing the interactions and the human-wildlife interactions at sea with this type of technologies that can be also, for example, incorporated with camera-borne systems that provide this information about interactions at sea. So what we've seen so far is the quantification of human activities at sea. This is very, very important for us to identify which areas were more exposed to changes amidst the COVID-19. And now we are analyzing how these have an effect on the sea, on human-wildlife interactions, for example, with this case of seabird-fishery interactions. We are also monitoring some other activities like boat anchoring in vulnerable habitats of the Mediterranean. We are assessing as well changes in the underwater noise, and finally the emissions of plastic and ghost gear due to these changes. So thank you very much. I'm looking forward for your questions and then contribute also in the following panel.
Thanks very much, David. The next speaker is Professor Christian Rutz. Christian has a broad interest in animal behavior and conservation, advanced wildlife tracking technologies, so-called biologging, and policy making. He's a keen field worker, and his research is driven by a deep curiosity about the natural world, as well as a steadfast commitment to its lasting protection. Rutz is a National Geographic explorer, founding president of the International Biologging Society, and co-founder and chair of the COVID-19 Biologging Initiative. He has received numerous honors, including a Rhodes Scholarships at Oxford, a Radcliffe Fellowship at Harvard, and most recently, an Explorer Club's 50s Award.
Last year, the international community agreed to set aside 30% of the planet's surface as protected areas by 2030. Now, the so-called 30 by 30 initiative is absolutely essential for slowing rates of biodiversity loss and for protecting the natural world. But we must urgently decide what we are going to do with the remaining 70% of the planet that will remain unprotected. The world's urban population is projected to surge from about 4.4 billion people now to about 7 billion people by 2050. And this dramatic urban expansion will drive land conversion on a planetary scale to produce food, clean water, housing, electricity, transport infrastructure, and so on. And we have a choice to make now. We either accept that these 70% of the planet that remain unprotected will effectively be written off to wholesale destruction and will serve the simple purpose of serving humanity's need for space and resources. Or instead, we come up with innovative solutions for mitigating humanity's impact on the natural world. I firmly believe that it is possible to build a future where humans and wildlife can coexist. And I also think that every one of us has to make a contribution in this effort. So why is it so difficult to find solutions to sharing space with other animals on this planet? The reason is that it's usually not clear which aspect of human activity affects wildlife the most. And this is nicely illustrated in this image here of this stag that is clearly thinking long and hard about whether to cross this road. And its decision may be affected both by the road itself, which constitutes a physical barrier cutting across the landscape, but also by those cars moving dynamically along the road. And perhaps there are people somewhere out of view that also affect this animal. And as a researcher observing this animal, I have no way of telling what matters most, the road or the vehicles or the people. But in early 2020, under the most tragic of circumstances, an opportunity arose to make progress with this really important research challenge. At the time, governments around the world had started imposing movement restrictions to curb the spread of COVID-19. At one point, about 4.4 billion people were under some form of lockdown. That's more than half of the world's human population. And that caused a sudden and dramatic reduction in human activity on a planetary scale, which in fact was so profound that my colleagues and I felt we needed a name for it. We called it the COVID-19 anthropause, quite literally a pause in modern human activity. And we realized that this was an opportunity to find out how wildlife behaves when there are fewer people and fewer vehicles moving across the environment. And very quickly, reports started appearing on social media and elsewhere of animals showing up in really unusual places. And many of you will have seen this now famous photograph of a puma prowling the streets of downtown Santiago in Chile in broad daylight. Absolutely extraordinary behavior. But we also know that some of the reports were fake. There were no dolphins in the canals of Venice. There were no bison in New York. And I'm pretty sure that Nessie didn't show up on the shores of Inverness. But how do we really know what animals were up to, given that researchers like myself were also sitting at home sheltering with their families rather than being out and about studying these animals? Well, before the pandemic, unaware of what was about to happen, researchers had deployed thousands of tiny tracking devices on wild animals as part of their routine research and conservation work. And these tags use similar technology to what we have in our smartphones and our smart watches. They allow high-resolution satellite-based GPS tracking, so we know where the animals go. But they also have little sensors that tell us what the animal is up to, whether it's sleeping or foraging and so on. And importantly, these tags remained active whilst half of the world's human population was sheltering at home. And importantly, they continued transmitting data via satellite uplink to the researchers at home. And this is when the penny dropped and some colleagues and I realized that if we could tap into this data goldmine, we would be able to paint a picture of what happened during this extremely tragic period of time. And we put out a call for collaboration to the international tracking community via the International Biologging Society, asking colleagues to contribute data sets of animals they had tagged. And we were absolutely overwhelmed by the response. We quickly formed a research consortium that now has over 600 partners. These colleagues have contributed data for about 13,000 tagged animals across about 200 different species, both marine and terrestrial. Basically anything that swims, hops, or flies. We now have well over 1 billion satellite fixes for animals. And we are pooling these data for collaborative analyses to see how animals move before, during, and after lockdowns. Of course, you all wonder what it is we've discovered, and the next speaker, my colleague, Dr. Marlee Tucker, will tell you about some results of one of our sub-projects that looked specifically at the movements of 2,000 terrestrial mammals worldwide. These results have just been published as the cover story of Science. But I want to give you a glimpse of what these lockdown responses really look like. We weren't offered data from pumas in Chile, where this amazing lockdown photo was shot I showed you earlier, but we got data from Chris Wilmers and colleagues from California. And this little yellow dot here is female 25, and she was tagged prior to the pandemic. And you see her moving across the Santa Cruz area here. Lockdowns were imposed on 17th of March 2020 in the area, about now, and you see that she starts exploring the landscape more widely. She probably by this time had noticed that there were fewer people, and now she makes these really deep incursions into the urban space, really unusual behavior. So we really see how these animals responded to lockdowns. Now, these lockdown analyses are really transforming our understanding of human-wildlife interactions, but by themselves, they cannot produce answers to how to build sustainable strategies for land conversion. Why? Because this wasn't a planned study. We responded to an opportunity that had arisen by pooling data that had been collected for other purposes. And that means that these data sets, large as they may be, are significantly biased. For example, most of our data come from North America and Europe, and we have a huge data gap from the global south. So we've only really seen half the picture. We've also been offered mainly data for some species that are of particular research interest, like large migratory birds. But we have no idea what many other animals were doing. And perhaps most surprisingly, most of the data we got access to came from relatively remote areas, undisturbed areas, protected areas. But it is, of course, human-modified landscapes in which we must track animals to really understand our effects on their movements. We know that land conversion affects their movement and behavior, but we don't really understand what the specific factors are that impact them so much. I have developed a vision for a groundbreaking new initiative that will fill this knowledge gap. It's the so-called Urban Exploration Project. It'll be the largest animal tracking study ever conducted, and the plan is to track animals along gradients of urbanization worldwide. The idea is to not just track animals in one location. This is London marked up here, or in 2, perhaps 10 or 20. No, the idea is to have about 250 teams that will track about 10,000 animals over the next 10 years or so. And importantly, these teams will be formally partnered. Every team in the Global North will be partnered with a team in the Global South, so we can share resources, research opportunities, expertise, knowledge, but also benefits arising from this work across this network. Importantly, these teams will be adequately resourced to do the work. They are the experts who know the animals, who know the locations, and they will be given the funding they need to do this tagging for the consortium. They are not going to be asked to gift their time and their data. And importantly, they will also get adequate resources to then feed our findings back into the local communities to push for positive change on the ground. So we will have a really innovative pathway for impact delivery. I firmly believe that the Urban Exploration Project will produce the transformative advances we need for building a future where humans and wildlife can coexist. And I also believe that we must not give up on the 70% of our planet that will not be formally protected. That requires immediate action, and it requires pooling of resources and expertise. And I hope that all of you will look for opportunities to join these efforts. Thank you very much.
Thank you very much, Christian. It was fascinating. Our next and final speaker is Marlee Tucker, who is an assistant professor at the Radboud University at the Department of Environmental Science. She is interested in large-scale patterns in ecology, biogeography, and evolution, and uses those that understanding to aid species vulnerability to changing environments that can be utilized for conservation. Her research encompasses macroecological questions related to allometric scaling, predator-prey interactions, and animal behavior. Her recent projects combine macroecology and movement ecology to examine how humans have altered animal behavior and the consequences of these changes for population and ecosystem processes.
Okay, thank you. Good evening, everyone. And thank you for Tom for inviting me and for organizing tonight. As introduced, I'd like to tell you a little bit about some of the work that we've been doing recently, looking at how terrestrial mammals responded to the COVID-19 lockdowns. With over 8.1 billion people inhabiting the Earth, we're currently living in the Anthropocene, a period of time of significant human impact on the Earth. And here are just a few examples of human impacts that we have on the Earth. And broadly, these can be categorized into two different categories. So we have land use change, where we've modified up to 70% of the Earth's land surface through activities like agriculture and urban expansion. But on the other side, there is also the human mobility component. So if you think about our daily activities, for example, we take transportation, use vehicles, which can create things like pollution, noise, and have other impacts on the environment and animals. Now, for many animals, humans and human-modified areas are seen as risky. So in many cases, animals will alter their behavior in order to minimize this risk and reduce interactions with humans. Of course, there are some examples, but generally, animals will either avoid areas where people are, or perhaps they use them at different times of the day, for example, becoming more nocturnal. Now in 2020, COVID-19 entered the scene, and as already been explained by several people and as we all experienced, different governments introduced different policies to try and curb the spread of COVID-19. And this was generally done by introducing lockdowns. And as a response of this, this severely altered human behavior. And as Christian already nicely introduced, this is an example of anthropause, where there was considerable global slowing of modern human activities. For example, transportation. Now, this period of time was quite horrific, but at the same time, it also provided an interesting opportunity and kind of a natural experiment where we could actually alter human behavior and see what impact that actually had on animal behavior. And obviously, this I said that human impacts comprise of both human mobility, but also the land use change. So land use change obviously stayed there, the roads stayed there, the cities stayed there, agriculture stayed there. It was just the human component that was modified. So what happened when humans were taken out of the picture? And as Christian already introduced as well, there was a lot of media around this, with suggestions that nature is healing. Certain animals are seen in places that they hadn't been seen before. In some cases, people took this a little bit too far, but generally there was a lot of hype about what was going on. And a bunch of us, being scientists, we were kind of wondering, okay, can we actually quantify this? Are animals actually responding to the lockdowns, or is it just that we're paying more attention to what's going on outside? So we published this work last year, and this work was a part of the COVID-19 Biology Initiative. Now, when I say a group of us, this is a large collaborative effort with over 150 different people from around the world who contributed data and discussions and helped to get this work completed. So I just want to acknowledge and thank everybody who was involved during this process. Okay, so how do you tackle such a big question? So what we did is we wanted to use GPS tracking data from terrestrial mammals, and we wanted to look at two different metrics. So the first one being movement. So this is basically how far animals travel. And the second one was distance to roads. So whether animals were closer to roads or further away from roads during the lockdown. And we compared two different time periods. So we had the lockdown. So whenever the lockdown initially started in the different study locations until the middle of May in 2020, compared to a baseline period, which was the same time span, but from 2019. We ended up compiling GPS tracking data from 43 different terrestrial mammal species, and there's some examples across the bottom of the slide here. So we had animals such as elephants, giraffe, different deer species from different places around the world. And on the map here, the black points represent the locations where animals were tracked. Now, the underlying map is a stringency index, which again, thank you to David for already introducing. So this basically represents how strict the lockdowns were based on the government policies. And this ranged from 0, so basically no lockdown, to 100, very, very strict lockdown, for example, in Italy. And the map here just shows you for different countries what the average stringency was during the lockdown period that we studied in this study. Okay, so what did we actually find? So first we'll look at the results for movement. And this is looking at movement distances over a 10-day period. And this basically represents sort of more long distance and ranging behavior of animals. And before I show you the results, just to walk you through what this plot means. Along the bottom, we have the stringency index, where 50 is kind of a medium lockdown, and 100 is very, very strict. And on the y-axis here, we have the movement effect size. So basically, if the value is 0, it means there was no difference in movement distances between the lockdown and the baseline year. Any values above this line, so positive values, indicate increased movement during the lockdown, and if any sort of negative values below this line represent reduced movement during the lockdown. So this is what we found. So if we focus first on the right-hand side here, we see a trend towards animal moving longer distances in areas of very strict lockdown. And on average, they were moving distances that were 73% longer. And this is probably as a result of increased permeability of landscapes. So humans were sort of removed out of the picture in these areas. So animals could potentially use areas that they were avoiding or were potentially exploring new areas. We can see here in the middle, it's a little bit of a mixed bag. Some animals were moving more, some were moving less. This is probably a result of the different government policies in this range of stringency index values, where in some cases a bit stricter, sometimes a little bit more relaxed. So we saw animals having a mixed response here. And then if we look on the left-hand side here, in the kind of medium lockdown areas, we see that movements were reduced. Which might be a bit counterintuitive. Okay, so if there were lockdowns, why were animals moving less? But if we think about what the lockdowns meant for these medium stringency areas, a lot of governments were actually encouraging people to go out into green spaces. Basically, it's good for mental health and getting exercise and fresh air. So in a lot of these areas, there was increased human presence in localized areas, specifically in parks and green spaces. And in some places around the world, these areas were being used up to 350% of the baseline. So you can imagine if these areas are being flooded with people, this probably has impacted how animals move and putting more pressure on those areas, so those animals tended to move a little bit less. Okay, what did we then find for the road distance? So we didn't find any effect of how strict the lockdown was, but we did see an effect of the human footprint index. So the Human Footprint Index is a measure of both direct and indirect human impacts, so things like roads, railways, cities, human population density. So it's a mixture of different human impacts, where 0 here indicates areas with very low human impact, and 36 represents areas of relatively high human impact. So here on the y-axis, we have road effect size. So again, 0 represents no change in distance to roads between the lockdown and the baseline. Positive values indicate being further from roads, and negative values indicate closer to roads during the lockdown. So here we see, particularly in areas of high human footprint, that animals were closer to road, and they were on average 36% closer to roads during the lockdown. This probably reflects that in areas of high human footprint, there tend to be a higher density of roads, but also higher traffic rates. So the lockdown would have had a bigger influence on this. So basically during lockdown, in many places there was reduced traffic and reduction in transportation. So it's probably why we see a stronger effect of animals being closer to roads in these areas. Compared to more remote areas, you can imagine that people are not probably visiting very often anyway, and lockdown probably didn't have too much of an effect of road use in these areas. And this is supported nicely by some other work. So there were traffic declines identified during lockdown. So in some areas, traffic was reduced up to 80%. Some other studies also found that there was reduced road mortality, so reduced roadkill in certain parts of the world. And our study indicates that animals are also closer to roads. So this combination of reduced mortality, but being closer to roads, indicates that there was reduced avoidance of roads during the lockdown, which is quite interesting because it shows that not just the presence of roads that might have an impact, but also how we use roads that are actually having an effect on animal behavior. So what does this all mean? So our results suggest that animals do retain the capacity to respond to changes in animal behavior, particularly in regards to their movement and their distance to roads. Their responses was over a relatively short period of time. So for some, it was over a month, and for some, a couple of months. We do see that there were highly variable responses, particularly for movement. So this is something that we'd like to look at a little bit more to see whether that's some indication of species behavioral flexibility or ability to adapt to human behavior. But it could also be potentially related to how humans actually responded to the lockdown. But overall, it does suggest that human mobility actually does have quite an important impact on animal behavior. And this indicates that sort of we're thinking about conservation, it's not just about protecting habitat. We also have to think about sort of our behavior and how we're using space as well, because it seems that it has quite a strong effect on how animals behave. So this could mean that perhaps we need some targeted mitigation, for example, thinking about how we can alter the frequency and timing of our movements, particularly in areas that are quite important to animals, particularly doing things like breeding, migration seasons. So perhaps we just need to give animals some space to kind of do what they need to do. But overall, I would say that these results provide some positive outlook for conservation, as it seems that, we can still make changes to improve sort of human-wildlife coexistence to what we have today. And yeah, that's everything from me. And thank you for your attention. And I'm looking forward to the discussion.
Thanks very much, Marlee. Now, I'd like to invite you to ask any questions to our panel. We've got a couple of roving microphones around, so if you do put your hand up, just wait for the microphone to make its way to you before you start speaking, please. Great, okay.
Thank you. I'll ask a question about from the beginning of the talks, particularly about the Chagos data. One thing I didn't understand, you may have said it, was that how do we know all these boats are there when they're not coming up on the satellite? And I also felt very disturbed to see so many red dots right in the middle of the Chagos archipelago. One wonders if the patrols are still going on, but that was it.
So maybe I didn't explain that very well. So so we know where they are from, not just the satellite data, and obviously the satellite data can't show us everything because a lot of it is turned off or they don't have it. But the other option for data is from the enforcement of the marine protected area, so just from that one patrol vessel. So every time they see a vessel, they'll record that it's there, and they'll also sort of write what it's doing. So it could be innocent. So they use a couple of different things to determine that. So whether or not they're fishing at that time, what type of vessel it is, because if it's like a tuna targeting one, they're less likely to be conducting illegal activity. And that's when they'll normally go up to them and approach them and board them at that point, just to ask them what they're doing and establish it. So that's the two data streams that we used to understand the patterns.
And the fact that a lot of these red dots, illegal fishing is in them right in the middle of them.
Yeah. So it's you get the two different types really. So a lot of the stuff that you see is sort of fishing around the border. It tends the sort of dots all around there, and that's almost like either accidental or just kind of chancing it because they know that the patrol vessel doesn't go there. But then those dots that are sort of in the middle, that just represents all the sort of shallow reef areas, which is where that they tend to be targeting a lot. So it has had considerable impact. So which we're just starting to understand through the research that ZSL scientists are doing. So a lot of, for example, shark populations have dramatically reduced during that time, and that's probably because of the Sri Lankan vessels targeting the sharks. So we can really see the impact that activity is having on those systems.
I've got a question as well. Roughly 50% of UK adults are reporting a greater use of outdoor spaces since before the pandemic. I guess my question is, for all the panelists, how do we ensure that this what seems to be a sort of a greater need for nature that's now being recognized? How do we ensure that the impacts of that isn't felt negatively, and that we ensure that things like ecotourism can be, developed sustainably? Christian, yeah?
Yeah, I'm happy to take that. First of all, to be absolutely clear, there is no need for humanity to remain in some state of permanent lockdown. So I think what these analyses show is that we can find ways of achieving sustainable coexistence in a way that we can enjoy nature, that we can enjoy the things we want to do outdoors, but at the same time minimize our impact on the natural world, including on wildlife. And I will give you an example. So in some cases, it may be enough to reduce human mobility in certain areas during sensitive periods. For example, the period of reproduction of particular species that live in an area. Example is sea turtles that need to visit a particular beach for laying their eggs. Well, that should be off bounds, but that still allows usage of that area in other periods of time. And I think our analyses provide pointers to where such opportunities exist. So we may, for example, have to rethink our transport networks or the way we pace traffic flow on that networks. But I see real opportunity for innovation here. I think this is something really positive that comes from this period of major tragedy, and something we can use and take forward and build a sustainable post-pandemic world.
Right. Any other questions? Yes.
Hi, my question's for David March. So lots of your work showed decreases in maritime traffic during COVID. Do you have any idea how that's changed since? Has it rebounded?
Well, as I mentioned, we mostly focus on the period till June, but this recent paper that came out several weeks ago, published in Nature, and they also combined these satellite imagery. They find out that in general there is a rebounding of the activity, and even in some areas like Chinese waters, there's been an increase of marine traffic. Indeed, that's one of the challenges. I think also we also want to take to address for future plans, also the maritime transport, how marine traffic and activities are gonna change. New routes are planned to be open even in the Arctic, and also we have these initiative, also these blue ilk plans from China, also to create new transfer routes through Southeast Asia, and to deliver and to have some new transports towards Europe. So yeah, definitely that's something that so far these new technologies are going to provide us new insights on how marine traffic and human activities at sea are evolving since that.
My question is for Christian Rutz. So you mentioned in your upcoming urban tracking project that you'd be partnering one team from the Global North and one team from the Global South. How are you planning to pair those teams together?
That's a really good question. So we are planning to build that into the study design and make it actually an initial condition for participation. So if you want to join the consortium, you have to join as a pair of teams. And if you don't have a partner, we will facilitate and help you find a partner. Of course, the ultimate vision is that not just these pairs will be partnered, but we will form this global network. But by building it into the design, we will ensure that we will address this bias we currently see.
So you mentioned turtle beaches and closing wild spaces, but your research is looking more at urban areas, which you couldn't just close to humans because it's where the humans live. So what kind of innovative ideas would you think could apply to that?
So with regards to the urban exploration project, the main focus will actually be on this peri-urban interface. So we've got a relatively good idea of how animals move in remote and protected and undisturbed areas. There's some good research going on in cities. Urban ecology is a fast expanding research field, but it is this interface where we need to do a lot more tracking, so we will focus our efforts on that area. And that for some reason is currently an area where very little research takes place, and that could reflect the preferences of funders, or it could reflect urgent research needs for endangered species. We don't know. And it's very important that what I proposed here is not considered to divert resources from 30 by 30 or other initiative. I see that as completely complementary. It's the flip side of the same coin.
Thank you. The question would be for Marlee Tucker. You mentioned also as well earlier, Tom, that people are going more to parks. Maybe your opinion on us taking part in the tracking, so citizens logging data on iNaturalist or websites like that, taking part in the usage of such data. What your opinion is on that?
Yes, thank you for your question. Yes, so I think I haven't personally worked with citizen science data myself, but I do think that's also quite a useful resource. And I know there's definitely been studies looking at sort of data that's been collected by scientists through different surveys and data that's been collected from citizen science. And actually they complement each other quite well. And actually there are gaps in like the traditional ways of collecting the information versus citizen science that can be filled with citizen science data. So I think that's quite a useful tool. And I don't think the findings from our study necessarily preclude citizen science from stopping. And in some ways, actually, citizen science is nice because sometimes it also gets into these areas, the more kind of urban, peri-urban landscapes, more so than the remote areas. So I think it's I think it's complementary, basically.
My question is to Christian. I was just wondering, once you have the network setup of Global North and Global South partners, what would your priority species be, considering that every species moves differently and also they interact with the humans as they move very differently from each other?
Yeah, that's a very good point. So the idea is to initially start with an open call, so there are no restrictions on the particular area or the particular species teams will study. But of course, at some point, we will have to steer that a little bit, because otherwise we again end up with a systematic bias, and we have a lot of data for some species, but very little for others. But this is something we will deal with as the project develops. But it's really important that we sample quite broadly across the tree of life. So we have all these different modes of using environments, all the different foraging behaviors, all the different movement types. So we have the data we need for making more general recommendations. That's a really good point.
Yeah.
Only if there's nobody else.
Yeah. I've got a question after you as well.
Thank you. Thinking about the 70% that's not going to be protected, I just had three things in mind. Starting off with the UK and particularly England, we've now got this net gain biodiversity notion that our planning is going to be a net gain from building houses on fields that'll somehow, improve biodiversity, which I hope it does. There don't seem to be any suggestions on road transport. One sees so many new bridges and things, and none of them are wildlife bridges, as you see in some places in France, for example. And another thought that occurred to me too was regenerative farming. I wondered what you thought about that. And anybody that wants to come in on those would be very welcome.
I will take the first point, because this is precisely what the Urban Exploration Project hopes to do. It'll try to generate the evidence base we need for deciding where those corridors need to be, what size the wildlife bridges need to be, how large does a habitat patch have to be, and what is the degree of connectivity we need to ensure across the landscape. All these are concepts that are theoretically well understood, but at the moment, a lot of the management implementation is based on human intuition. We say a wildlife bridge must be better than no wildlife bridge, but we are basically operating in an evidence vacuum, and so we hope to fill that knowledge gap so that we can make informed decisions. Perhaps one of the solutions is to move a lot of road traffic underground. I see real opportunity for innovation there, but in order to make informed management decisions, we need to know what the animals need to express their natural behavior.
I read today that there's a road closed somewhere in England to allow toads to cross, a complete stretch of road, but I don't have any more detail.
I've got one question, and then just again to the entire panel. I was wondering if there was any parallels you could think about, given your own individual expertise. Are there any novel kind of analytical approaches? For example, I'm interested in trying to forecast where illegal fishing might be happening. Are there any lessons to be learned from how animals change their movements given the opportunity to do so? And vice versa, are there any lessons from how vessel traffic changed, illegal fishing behavior changed, that could be used towards animal movement analysis? Difficult. Nobody wants to step outside their field. It's a typical problem in research.
I can start.
Yes, well done.
my points. And I think also by looking at some of the innovative aspects and also following some of the previous comments that we are addressing in terms of, for example, in terms of fisheries. Of course, what happened with this 70% that is remaining, and some of the innovative tools we address is this concept of dynamic ocean management. Think about this transition of static marine protected areas to dynamic marine protected areas that adapt to the changes in the movement of the animals, of migratory species, large marine vertebrates that change the foraging behavior accordingly to environmental drivers or phenological aspects of the biological component. So if we put in top these layers of human activities at sea, fishing activities with a spatial distribution of marine animals, we can look at these overlaps and optimize this protection at sea and implement management efforts that consider this dynamic nature of both animals, but also human activities, trying to reach to a trade-off and look for sustainable development of the activities at sea. So that's potentially the points that we are now looking at, and of course, I think that the analysis we've done with the marine traffic is providing us some new insights in a very, let's say, in a temporal resolution that we were not looking at before in terms of these overlaps between human activities and marine animals.
Okay, thank you. Just one final question, and then I think we will bring this evening to a close, perhaps. Oh, there's one more.
Thank you.
Yeah.
You all variously touched on the importance of engaging global and local communities. I think my question centers around how do we continue to empower those people? How do we continue to engage them with why the work that you all do is important? And also, how do we understand why they're behaving at the moment in ways that aren't necessarily long-term beneficial to them? I'm thinking in terms of Chagos particularly, but also like in terms of local communities more broadly.
I guess I can say a little bit on that. So I think, yeah, one of the sort of key learnings around particularly Chagos is that like no MPA is an island, like if that you can say that. So even if you're considering making these like remote LSMPAs that, you know, where no one lives, that's not the reality of the situation. So like, you know, socio-ecological systems are sort of, you know, the social and the ecological is intrinsically linked. So I think that's and we haven't necessarily managed to do that effectively with marine protected areas, I would say, like globally at the moment. So I think there does need to be sort of continued efforts to link up the social aspects of marine protected areas, even when it seems like they're really remote, because ultimately that's going to determine the success of these areas. So it's just ensuring that it's like at what stages, so during implementation, but also like meaningful engagement rather than just sort of, you know, sort of touching base and communicating. Is about how like people to actually get invested in designing it and being sort of like stewards of these areas as well is really important, I think.
I will go absolutely last because this is in a way nothing to do with what you're discussing here, but there's one big gap in your knowledge when all this monitoring has been done, and that is what is happening to plants. Around the world, lots of habitats of plants are being destroyed, or plants are advancing and making use of habitats created by man. In this country, all natural habitats are man-made. Ancient woodland was fenced for 1,000 years with no animals in it. And it would be very interesting to discover what the state of plants around the world with increased monitoring like this, and also fungi.
I guess one way to answer that question is to first redo the analysis, but only looking at herbivores. Yeah. I'll tell you where they've improved.
No, that's a very good point. I mean, there are so many different facets to this puzzle, and when you look at the academic literature on these lockdown effects on the environment, that is exploding. And I'm pretty confident. I'm not aware of a study that looks at what you just asked, but I'm pretty sure that people are actively working on that. The research community really has come together in a really amazing way in this period of crisis to learn as much as we possibly can. And it's important to remember that all these hundreds of researchers Marlee mentioned and others mentioned who contributed data, who joined these efforts, they were also struggling with this unfolding crisis. Yeah, it's really inspiring to see, I think, how people have come together.
I think that's a great point on which to bring this to a close. I want to thank all the speakers so much for making tonight's event and really contributing, all your work this evening. Thank you everyone also for braving the horrible weather. I realize it was a difficult day. And also finally, thank you, Harriet, and the organizing committee for putting this together. Thank you very much. Thank you.